Hi, welcome back to LeetCode. So in this video, I'm going to discuss the first problem from today's biweekly contest 169. The problem name is count average with majority element 1. So you are given an integer array names and integer target. Okay. Return the number of average of names in which target is the majority element. So honestly, we will say that this actual majority element. So it will be majority element of a subarray is the element that appears strictly more than half of the times in that subarray. So that means we have to count the subarrays. Like for this example, first example 1, 2 to 3. This is the integer array and target is 2. So that means we have to find out how many subarrays are there in nums input array. Or actually the majority element actually is 2. Correct. So 1, 2 to 3. This is the input array 2 to 3. And we want that majority element should be, so target here it is 2. Alright. So first of all, what we can do? First of all, generate all possible subarrays. One is 1, another is 1, 2, 1, 2, 2, and 1, 2, 2, 3. Alright. This is the all subarrays starts with 1. Next is 2, 2, 2, 2, 2, 3. This is all subarrays starting with 2. Next is 2, 2, 3. This is starting with 2, but this 2, second 2. Next is starting with 3. So this is the only subarray possible, right? Starting with 3. So here you can see that we want to know that how many target is present, target length, then check that is target is greater than length by 2. Alright, so to check that, right, for all the subarrays. So target means how many times target count, and length is the length of the subarray. So for this example, first subarray, how many target actually I have seen? Target is 2, so this is 0. Length is 1. So is 0 greater than length by 2? That means 0.5. No. So this is not a valid subarray. Next is how many times target is present? This is only one time. Okay. And what is the length of the subarray? That is 2. 1 and 2, two elements are present. So now we will check that is 1 greater than 1, means 2 by 2. No. So this is not a valid subarray. Next is this subarray. How many times I have seen the target element? 2 times. And what is the length of the subarray? That is 3. But now we will check that is 2 greater than 3 by 2. That means 1.5. Yes. So this is a valid subarray. Correct. This is a one valid subarray. 1, 2, 2. Next, go to this subarray. 1, 2, 2, 3. So how many times I have seen these 2 times? What is the length of this subarray? 4. And is 2 greater than 4 by 2? 2. No. So this is not a valid subarray. So next is this. So how many times I have seen target 2? Only one time. What is the length of this subarray? Only one element is present. So length is 1. Okay. Now to check that to get a is it majority element or not. So what is the condition to be a majority element? So we have to check that is how many times I have seen the target element, is it greater than length by 2? 1 by 2 means 0.5. Yes, 1 is greater than 0.5. So this is a valid subarray. Next is this subarray. How many times I have seen target element 2? 2 times. Okay. What is the length of that subarray? 2. Is 2 greater than 2 by 2? Yes. So this is also a valid subarray. Next is 2 to 3. So how many times I have seen the target element? 2 times. What is the length of the subarray? 3. 2 to 3. 3 elements are present. Now to check that is it majority element or not. So what is the condition? 2 should be greater than length by 2. So that means 1.5. Yes, 2 greater than 1.5. So this is also a valid subarray. 2 to 3. Next is this 2. This 2 also same this subarray. So this is also a valid subarray. So I don't need to check that again. Next is 2 and 3. Let's see. So how many times target is present? Only one time. What is the length of the subarray? 2. Now we would say that 1 is 2 by 2. 1 is greater than 2 by 2 means 1. No, 1 is equal to 1, not 1 greater than 1. So that's why this is not a valid Subarray. Next is 3. How many times I have seen target element 0? What is the length of that? 1. So 0 is greater than 1 by 2 means 0.5. No, 0 is less than 0.5. So this is not a valid Subarray. Now after this, how many times how many Subarrays I found that the majority element is target? This is 1. This is 1. This is 1. This is the 1. And this is the 1. So how many Subarrays? 1, 2, 3, 4, 5. So I have to return answer is 5. Clear? Now let's see the output of this example. Yes, output is 5. Clear? So how we can solve this? So the problem statement is clear, right? Now how we can solve that? So first of all, what we can do? First of all, generate all possible Subarrays. Right? Then actually iterate all Subarrays, and count the target numbers in each Subarray. Now we have to check that is it count of the target element is it greater than length by 2 or not. If it is greater than, if it is 2, then we have to increase our answer value by 1. Else I will go to the next Subarray. So we all know how we can generate Subarray, right? If you don't know, so just explaining the logic to generate. Suppose 1, 2, 3, 4. So we can take 2 pointer. One is the left pointer, right pointer. Left pointer will indicate that this is the starting element of the current Subarray, and R is the ending of the current Subarray. So that means now I want to generate all possible Subarrays starting with 1. Okay. So first element is 1. Next, I will not shift the left pointer. First, I will shift the right pointer. Okay. So now it will be 1, 2. Next, right pointer to right side, 1, 2, 3. Next, shift the right pointer to the right side. It will be 1, 2, 3, 4. Clear. Now, whenever reach the end of the input array, so that means we have generated all the possible Subarrays starting with the current left pointer. So now after that we will shift the left pointer to the right side. Now left pointer is pointing at 2, and again I will reset the right pointer to also the 2. Okay, again I will start all the possible Subarray 2. Again I will shift the right pointer to the right side, 2 and 3. Next I will again shift the right pointer to the right side, 2, 3, 4. Clear? So in this I can generate. So what is time step for that? So you can see that for each L I will iterate the R, right? For each, because I will first fix the left pointer because that indicates that this is the starting element of the current Subarray. Now I will try to generate all the possible uh, ending of the current Subarray possible. So that means you can see that for this L, I will one possible endpoint is actually 1. Next endpoint is possible 2. Next is 3. Next is 4. So that's why for each L position I have to iterate R number of position. So how many L position, like the left position, starting element of position possible, that actually 4. That means n. And for each left position or the starting position, I have to iterate the R number of times. So that means R is possible again in roughly we can say. So here actually you can see that it will take actually n square, right? Time will be n square. Clear? Generate all possible Subarray, then actually it will take n square time study. Clear? Why actually it will take n square? If you had any doubt, you can comment on that. I will create another video to like problem statement something like try to generate all the possible Subarrays. Okay, in any input array, from any input array. So this will take big of n square. Now I have declared all the possible Subarrays and count the target number in each Subarray. So how many actually Subarrays are possible? N square number of Subarrays are possible. Okay. So it will be n square, and for each Subarray, I have to count the target element is present. That we have to count. So we can actually assume that um, the length of the Subarray is n. So I have to check each element of that particular Subarray, that is it target or not. If it is target, then I will increase the count. Else I will not. I'll go to the next element. So if the length of the each Subarray is n, so it will take n cube. Why n cube is clear? Because the number of Subarrays, it will be n square, and the length of the Subarray is average length of the Subarray is n. Then I have to go to each like I have to iterate all the elements of any of each Subarray. So that's why it will take n cube to get the count of each target. So after iterating the one Subarray, I will get one count variable, that how many times I have seen the target in this current Subarray. So then I will check that, okay, is it majority element or not. So that's the condition, is that count should be greater than length by 2. If it is true, then I will increase the answer variable. Else I will go to the next Subarray, and whenever I complete all the Subarrays, then I will return this answer variable. So ultimate from this approach, the time velocity is nq, right? So here actually n value is 10 to the power 3. Length of the array can be 10 to the power 3. So nq, it will be 10 to the power 9. So which is actually greater than 10 to the power 8. So we all know that, we assume that we can actually process 10 to the power 8, right, operation or command at a time in 1 second. So it will give us clearly, right? So that's why we have to think about any optimal approach. So actually you can see that we're actually storing all. Why it's taking time? Because we know that there is n square number of actually Subarrays are possible. So do we need to? They do not want to know about the Subarrays, right? If they want to know that we have written all the possible Subarrays, then actually we have to think we may need to store the Subarray. But here actually we only need to know the count of the target, because ultimately whatever we are taking, that actually that the count number of target in the Subarray is should be greater than length by 2, right? So that's why I need to know only the how many times I have seen the target element. So that's why whenever like I have already shared this approach to generate the Subarray. Now we can actually use that logic here also to get the count. How? Just if actually use another variable here. How? Suppose we actually have 1, 2, 3, 4. Okay. Now we actually want to know how many times in how many times I have seen the target T in the current Subarray. So I know that this will be the left pointer and this will be the right pointer, right? So I will, this is a new Subarray starting with 1. So I will reset this count variable as 0, because I have not seen any target element in this current Subarray, because it's a new Subarray I'm going to generate, and the length of the Subarray should be 0, right? Now what I'll do, I will generate the first, I'll take the first element, that means 1. Is it equal to target? Suppose target is 2. No, so I'll not increase the count, but I will increase the length of the Subarray, because I'm going to insert one element, right? Okay, next is 1, 2, because I will shift the right pointer to here. So okay, 2 is the target element. Yes, so I'll increase the count variable by 1, but anyway our length will be increased, because this is a one element being inserted into the Subarray. So now to check that this one is greater than 2 by 2, because I know that the length of the Subarray is 2, and what is the condition to be a majority element? The condition is that whatever the number of target is present, that should be greater than 2 by 2, means length by 2. So this is not true, so that's why I will not increase our answer. Answer is that we have to return increase is 0. Okay, next I'll going to insert 3. So that means our count is still 1 and our length will be increased by 3. So means by 1 it will be now 3. Next is I will going to insert 4, because right pointer shift to the right side 4. So length will be increased by 1, it will be now 4, and count is still 1. Got it? So next You can see that I have already generated all the Subarrays which starting with 1. Next is what? Now try to generate all possible Subarrays starting with um, 2, next element. So again I'll reset this count as 0 and length is also 0 because this is new Subarray I'm going to generate starting with 2. So I will reset this because I have not seen any target element till now and length is also 0. Now left pointer is pointing at 2 and right pointer is pointing at 2. So now you will see that okay, is this current element 2 is a target element? Yes. So I'll increase the count by 1 and length is anyway going to increase by 1 because this is a new element going to insert. So now I have to check that is it majority element or not. So the condition count should be greater than length by 2. So 1 should be 0.5. Yes, this is true. So this is one possible Subarray, or actually I've seen that count is the number target element is a majority element. So I'll increase the answer value by 1. Correct? One minute. So this is clear. So you can see that we can use extra one variable in when we are trying to generate new Subarray. Directly we can use a one extra variable by which we can decide that how many times we have seen the target element in the current Subarray. Right, by using two variable, one is the count, number of target I have seen the target element, and length is indicated that what is the length of the current Subarray. Right, because to decide that is this Subarray is a target element is a majority element or not, we need actually two things. One is the number of times I have the current target element present, and another is the length of the Subarray. Right. So that's why we can optimize this. Then actually you can see that. Let's see another example 1, 2, 2, 3. This is this example, right? 1, 2, 2, 3. Yes. So target is 2. So first of all, left pointer is pointing here, right pointer is pointing here, and count is initialized to 0, and length is also initialized to 0, right? So now I will first add 1 into the current Subarray. So is 1 is the target element? No. So I will not increase the count, but I will increase the length of the Subarray. Now to check that yes, is this 0 greater than 1 by 2? No. So this is not a valid Subarray. Now go to the next element 2. So I will insert this 2 into the current Subarray. Is 2 a target element? Yes. I will increase the count by 1 and length anyway increase by 1, so it will be now 2. You can see what is the length of the Subarray? 2. And how many times 2 is present? The target element is present 1. So the state is consistent, right? So now I want to check that this Subarray 1, 2 is this actually a majority element or not. So what is the how many times I have seen this 2 target element 1, length is 2 by 2, is 1 greater than 1? No. Okay, next is I will insert this 2, 1, 2, 2. So 2, this new element is a new target element. So I'll increase the count by 1. So it will be now 2. Length is increased by 1, so it will now 3. So you can see that 3 length is 3, 1, 2, 2. And how many times the target element is present? 2 times. This is the one time, this is the second time. And so now I have to check that this is a majority element or not. So 2 greater than 3 by 2. That means 1.5. Yes, this is true. So this is not as a one correct Subarray. So answer will be increased by 1. Clear? Next right pointer shift to right pointer to here 3. So 1, 2, 2, 3. So count will be increased by 1? No, because the whatever is the number going to added into the new Subarray, that is the 3, not a target element. So I will not increase the count. And length will be increased by 1, now it will be 4. Got it? Now to check that how many times count is 2, length is 4 by 2, 2 is greater than 2? No. So this is not a valid Subarray. So you can see that after this I have generated all the possible Subarray with starting with 1. So after that you can see that I have to reset this count variable and length variable with 0 and answer is still 1. You can see that only one Subarray is possible starting with 1, or the majority element is 2. Correct? This is only possible Subarray 1, 2, 2. Okay, next is I'll shift the left pointer to the 2 and right pointer to 2. Now, so I'll again start from here. So new first element I'm going to insert 2. So count will be increased by 1. Yes, because this is a target element, so all count variable will be increased by 1, and length anyway it will be increased by 1, because whichever number, it may be target, non-target, it should be increased by length by 1, right? So now we have to check that if this is a measured element or not. How we can check that count value should be greater than length by 2. So this is 0.5, 1 greater than 0.5, yes, so this is a valid subarray. Next, right pointer will come to 2, that means 2, 2. So count will be increased by 1, so now it is 2, length will be increased by 2, so 2 is greater than 2 by 2, 1, yes, so this is also a valid subarray. Correct. Next I will come to 3, so 2, 2, 3. So 3 will increase our count value, no, because 3, whatever the new number I'm going to insert, that actually 3, not a target element, so it will not increase the count of target. But length will be increased by 1, now it is 3. Now to check that this is a majority element or not. So 2 should be greater than 3 by 2, means 1.5. Yes, this is true. So this is a valid subarray, right? So you can see that our answer will be increased by 2, that will be the 3, and next is 4, right? I got it to 3 subarray, 1, 2, 3. Previously it was 1, starting with 1, answer was, now it is for second one, third one, fourth one. Clear? So I have generated all the possible subarray starting with these 2. Next I can start with next element. So again it will be reset to 0, and this is the left pointer now, and this is the right pointer. Answer is still 4. The state is consistent, right? All the state is clear. Answer, why the answer variable is still 4, why the count variable is 0, length is 0. Clear? Next I will add this element to our subarray 2. So is this increase our count? Because yes, because this is our target element, so our count will increase by 1, and length anyway will be increased by 1. So now to check that is this a target, is this a majority element or not? So what is the condition? 1 should be greater than length by 2. That means 1 should be greater than 0.5. Yes, this is true. So again our answer will be increased by 1. So this is 5 now. Got it? Next I will insert 3. So 3, whatever the new number I'm going to add, is this a target element? No. So our count variable should be 1. And length will be increased by 1, so it will be now 2. So now what is the condition? 1 should be greater than 2 by 2. Yes, 1 greater than 1. No. So this is not a valid subarray. Now we have generated all the possible subarrays starting with these 2. Now go to the next element, shift the left pointer, then again we have to reset this count variable and length variable. Clear? With 0. That will reset to 0. This will be reset to 0, and the left pointer is pointing at 3 and right pointer also pointing at 3. So I'll add this 3. Is 3 a target element? No. So count will not increase, the length will be increased by 1. Okay. So now to check that this is a majority element or not. 0 should be greater than 1 by 2. Is 0 greater than 0.5? No. So this is not a valid subarray. So our answer is still 5, and we have generated all the possible subarrays, right? So this actually help us to solve this by in square time only, because we are not actually after generating all possible subarrays, then actually we are not iterating all over them to find out how many times I have seen the target element, because whenever we trying to generate all the possible subarrays, then actually we can count that, right? Because the target variable is only 1, correct? Fixed. We before generating the subarrays, we know that what is the target element. So that's why we can use that logic here, that we will take one variable to check, to count that how many times I have seen the target element, and we anyway know the length, so we don't need to check. We don't need another steps to count that, right? So for that, it will actually solve this big of n square. Clear? So now go to the code. So you can see that first of all find the input array length in, and answer is the indicate that how many actually subarrays are possible where the target is the majority element. Correct. Now we have seen the logic to generate all the possible subarrays with two pointer. One is the left pointer and another is the right pointer. So left pointer will start from 0 to n minus 1 because all number can be the starting number of a subarray. So for each subarray, we have to fix the left pointer. That means we are going to start a new subarray starting with the current number L. So that's why we have to reset that. Here I already explained that when I actually shifting the left pointer, I will reset this count variable length variable to 0. So similar way I am doing this here also. Count variable and length variable also reset to 0 each time because this left pointer actually it will be increased by 1. Again it will come to this line number 8. So I'll reset this to 0. Got it? Now what will do, this for loop will actually shift the right pointer only. So that means it actually indicates the new number is going to add into the subarray. So it will start from L because this is actually the maximum left or the starting maximum number I can add, elements I can add into the subarray. So that is the left index of L, left pointer, and it can go up to n minus 1. So R plus plus. So each time until I am going to add any new number into the subarray, that will be nums of R. I will check that is this a target element. If it is target element, I will increase the count of that target element because that indicates that now actually I have one more element into the subarray for actually target element is present, right? And anyway, it is a target or non-target, I will increase the length of the subarray. Clear? Because our subarray length will be increased by 1. Clear? These two things will be clear. This if block and this length plus plus. Easy, right? Next is I'll check that. Okay, I know that how many times I have seen that target element into the subarray, and I know the length of the subarray. Alright, now to check that this target element is a majority element or not. So what is the condition? So that should be length by 2. So what is the count? That should be length by 2. Here what I have used? Like what is the condition actually? Count should be greater than length by 2. What if I have used that? I should multiply with 2 both sides. Length by 2 into 2. So what will do? This 2 will be cut. Now you can see that count into 2 should be greater than length. That actually I have used here. You can also use the same logic also here also, length by 2 also. If I use the count into 2 should be greater than the length. Clear? If it is true, that means this is a majority element. So I'll increase the answer value by 1 because I got a new subarray. And after checking all the possible subarrays, I will return the answer variable. That actually indicates that what is that how many times I have seen the subarray, or actually the majority element is the target. You can see that what is time series for this? Only one for loop here, L. So it will be of n. You can see the range 0 to n minus 1. Okay. For each L, I actually have one nested for loop for R. So range can go up to 0 L to n minus 1. So roughly you can assume that it can actually, in the worst case, it can be n times this R loop, this for nested for loop will run 10 times. So this is actually n square, nested for loop n square. Got it? Directly you can see that the input array length is actually 10 to the power 3 maximum. So it can actually 10 to the power 6 maximum. So it will actually pass, right? I have shared this code in the description. You can check that. And if you have any suggestion, you should comment on that. And if you are not yet subscribed, please subscribe channel. Thank you.